Hello. So here we continue our discussion of Haugeland and computers and on the notion of a formal system with the topic of formal equivalence and medium independence. You remember then that every formal system is digital. And one important consequence of this, as we'll see, is that two systems that seem to be quite different in appearance may nevertheless be essentially the same. So this means that essentially the same formal system can be materialized in any number of different media, with no formally significant difference whatsoever. And this is an important property of formal systems in general, which Haugeland calls medium independence. Now, what is medium independence? Well, a system is medium independent if what it is independent of the physical medium in which it is implemented. For instance, for chess, what matters is the identifiability of both the type and position of each piece. It doesn't matter what shape, size, or color either the board or the pieces have. So the pieces could be gigantic or tiny. They could be cookies or salt shakers. Haugeland gives even more far-fetched examples. So he writes, Texas millionaires, for instance, could play chess from their opposing penthouses using 32 radio-controlled helicopters and 64 local rooftops. Or if they owned an 8-story hotel with 8 rooms per floor, they might use brightly marked window shades, which the hotel staff redistributes on command. Now compare with football or hockey. So doubling the dimensions of a football field would make the game significantly different. If the ball were magnified by 20, not to mention replaced by a helicopter, nothing resembling ordinary football could be played. Now compare with the computer chess and computer hockey. So when you're playing chess in your computer, in your chess game app, you're actually playing chess. However, when you're playing computer hockey, you're not actually playing hockey. Why? Because chess, unlike hockey, is a formal system, which is medium independent. Now let's press forward to another important notion, which is that of formal equivalence. Now, two systems are formally equivalent if and only if, first, for each distinct token or position in one system, there is exactly one corresponding token or position in the other system. And whenever a move would be legal in one system, the corresponding move would be legal in the other system. For instance, take a game, let's call it 15. Now here there are 9 numbers, 1 through 9. And then A and B take turns drawing numbers from the list without replacement. Now, whoever first gets 3 numbers that together add to 15 wins. So the possible outcomes are A wins, B wins, and neither A nor B wins. Now, suppose that the game goes like this. So at the top, we have the numbers that are available, and then we have player A and then player B. Okay, the first game is player A takes 1. 1 is no longer available. And then the second turn, so now player B takes 8. Then player A takes 5, player B takes 4, and, well, it's not unsurprisingly, player A takes 9, and then they win. And so here we have a description of the game. So at the left column we have the available numbers, then the next column we have the moves made by the players, and then the number in possession in each player. Now I'm going to ask you a weird question. Are you ready? Okay. Were A and B playing tic-tac-toe? In order to answer this, first look at this square. It is called a magic square. Do you know why? Now, there are no bunnies coming out of it, but the reason is that each row, column, and diagonal adds to 15. So go ahead and convince yourself. Okay, suppose that we assign each of the squares in a tic-tac-toe a number, right, in the following scheme. The top left is 4, top mid 9, and so on and so forth. So that means that when A took number 1, his twin was doing the corresponding action of marking an X on the center bottom square. Likewise, when the opponent took 8, the equivalent action is to mark a circle on the bottom left circle, and so on. And of course, that means that A wins again. Why? Because having lined 3 X's in a row occurs only when in the other game you have 3 numbers that add up to 15, and the same in the other cases in which you can win in tic-tac-toe. You can invent another similar game but with words. It's like 15, but the words here are brim, ship, woes, form, here, hot, tide, tank, wasp. And the winner is the first to get 3 words with the same letter in common. And well, you can see how this game went by mapping the corresponding actions. Well, the idea is that here you have the parallelisms between tic-tac-toe, 15, and initials. So you have a characteristic in terms of the numbers, in terms of the squares, and in terms of the words. But you can see that in a sense, all the 3 games are the same game. It's just that you can distinguish the kind of tokens in each game. In tic-tac-toe, the tokens are individual marks. In 15, the tokens are numbers, whereas in initials are letters in words. Okay, in the types in tic-tac-toe, there are only 2 types, which are cross or X and 0 or O. In 15, the types are the groups in pile A and those in pile B. And in words, you have the initial stack A and the initial stack B. What is the key property of tokens? Well, in tic-tac-toe is the cell that it occupies, reposition. In 15, it is a numerical value. What about word? I'll let you fill it in. Of order triples, right? Of numbers. Right? And that would be chess. That corresponds at a higher level. It corresponds to a game of chess. And so the numbers of medium independence and formal equivalence are very important, are crucial to the computational view of mind. So brain cells and electronic circuits are manifestly different media. But maybe at some appropriate level of abstraction, they can be media for equivalent formal systems. And so at some abstract level, it is said by computationalists, the brain or parts of the brain it would be formally equivalent to a computational system. And so the formal system would be a program for cognition. So far we have the notion of thinking as computation, and then when on the notion of computer, we have introduced the notion of a formal system, right? Characterized as token manipulation systems, which have the property of being self-contained and digital. And we just discussed the notions of formal equivalence and medium independence. Now in our next video, we're going to introduce the notion of an automatic formal system. Okay, cheers. With the initial state in tic-tac-toe is the empty board. In 15 is the empty piles. The same with words. What constitutes a move in the game? Well, in tic-tac-toe is to write a mark. In 15, it is adding, namely a number to the pile, and in words, it is extracting the initial letter. What is the rule for an allowable move? Well, in tic-tac-toe is to write a mark in an empty cell only. In 15 is to take a number that is not in any of the piles. And what is the winning state? Is to have 3 marks in the same row, 3 numbers adding up to 15, and words is sharing a letter. You have 3 words that share a letter. So you have a 1-to-1 correspondence in the 3 games in terms of tokens and properties of tokens, initial states, action moves, and goals. That means that if you start off by playing one game and then change to another, nothing has really changed. A and B may start by playing tic-tac-toe, and they, go have a bite, they go back to play, and then start playing 15, because basically the same game. You could have a more abstract correspondence, for instance, in which tokens might be pieces of paper. For instance, playing chess, tokens would be pieces of paper with 3 numbers in a particular order, and the players take turns writing and submitting the tokens. And you can represent chess relations as numerical relations among the order triples. You know people who play chess by correspondence, when people used to send snail mail, and they would use kind of the algebraic notation. You have an order triple with rank and file and the number corresponding to one of the pieces. You have one in the first place, one number from 1 to 8, another one from 1 to 8, another one to 1 to 16. And so the game is simply a sequence of order triples of numbers. Right? And that would be chess. That corresponds at a higher level. It corresponds to a game of chess. And so the numbers of medium independence and formal equivalence are very important, are crucial to the computational view of mind. So brain cells and electronic circuits are manifestly different media. But maybe at some appropriate level of abstraction, they can be media for equivalent formal systems. And so at some abstract level, it is said by computationalists, the brain would be formally equivalent to a computational system. And so the formal system would be a program for cognition. And so far, we have the notion of thinking as computation, and then when on the notion of computer, we have introduced the notion of a formal system characterized as token manipulation systems, which have the property of being self-contained and digital. And we just discussed the notions of formal equivalence and medium independence. Now in our next video, we're going to introduce the notion of an automatic formal system. Cheers!